we made some initial concepts that light has a very short wavelength. So normally, in a regular way, we can't demonstrate interference in light. So it's very difficult. So we need a very, very narrow slit. We discussed this concept that instead of using two sources, these people decided for a smart approach, and they took a single source with a double slit. A single source with a double slit will guarantee coherence. And this was a sheet I had asked you people to write down in, and I had posted it on the group also. We were here. We were on this concept that we have a double slit and single slit, which is optional. And when we do this, when we run this apparatus, we get a very bright fringe at the center. Now, I think we had copied this. Can you check this? What was the last thing we did? I think this was the last thing.
1 second, sir. Yes, sir, I'm pretty sure it's this.
Right. So we are updating the diagram. Now I'm showing two dimensions, X and Y, which is an idea of trigonometry, which was necessary to highlight, because normally what happens when people are attempting a pure physics paper, normally they do not consider trigonometry is a main tool, but trigonometry is really a very important tool. You look at here, if I take the distance X and I take the other distance Y, I can find the angle theta, which is actually equal to tan theta is equal to y upon x. Remember, tan theta is opposite upon adjacent. You have to update the same screen.
Sir, can we have a 5-minute break for prayer?
Okay, you have the prayer now? Okay, fine. Go ahead, please. No problem.
Thank you, sir.
Now, after copying this, copy this diagram. Sure.
Done, sir.
Right. Just let's see that what we have done. We have mentioned the letter X. Now, this is a very important formula of this very important topic in this very important chapter. Superposition is considered to be the most important chapter in our whole course, the most challenging one. Within superposition, this is the main topic. Now, I have shown the formula x is equal to lambda d upon a. You have to copy this screen.
Done, sir.
Okay. Ariba, let me know if you are back. Ariba, if you can hear me, please respond if you are back.
Yes,
Okay,
I'm
good.
back.
So this is the formula. Now we move to our next title within the same topic, determination of wavelength of light. Now this is our next heading. Determination of wavelength of light. So this is the apparatus. Apparatus is not important. The main thing, it is Young's double slit experiment, the same apparatus. We know that what is x, what is lambda, so we can rearrange the formula to find the value of the wavelength. So after giving the heading right under it, using Young's double slit experiment, using Young's double slit experiment, using Young's double slit experiment, wavelength of light can be determined. Wavelength of light can be determined
Done, sir.
so we can rearrange the formula and we can put all the values in it, and using the values we can find the wavelength. Now we go to our next title. In the same, young double slit is continued. It's a big topic, heavyweight topic. Factors affecting the interference pattern. Factors affecting the interference pattern.
Done, sir.
Now this is the source, A is the slit separation, and I mentioned that now we are making some changes. Number one, I have made lambda x and A stub separation. I have made lambda and D constant. Now, if I change the slit separation, the fringe separation change oppositely. It means look at these two diagrams. Large fringe separation for small value of A and fringe separation decreases when slit separation increases. What is important from mathematics? It's visible, inversely proportional. What is important is the visible appearance. What happens when fringe separation increases? You will see few fringes, but when fringe separation decreases, there are many fringes on the screen. So this is the difference. Now you have to copy this screen.
Done, sir.
Done, sir.
Now look at the case when value of A is less. The fringe separation will be high. It means less fringes on the screen. And when you increase the slit separation, X decreases, so fringes will be closed. So when A is increased, X decreases, more fringes on the screen. Bright fringes, no change. Dark fringe, no change. This is one of their favorite questions, and they ask that in Young's double slit experiment, what happens when you make a particular change? You have to copy this.
Done, sir.
Right.
Answer.
Number 2, one slit is closed. One slit is closed. Now look at this. This is a double slit. If I keep only one slit open, then it will be a simply diffraction pattern and it will appear like this, but it won't be a typical interference pattern. After copying this, you have to copy this screen.
Answer.
Now write under it, if one slit is closed, so write under it, when one slit is closed, it is only a diffraction pattern only a diffraction pattern Number 3, x is equal to lambda d upon a. X is proportional to d. Lambda and a are kept constant. D increases. So it means if you increase the separation from the screen, if you move the screen backward, you will see intensity decreases and the fringe separation increases. The envelope expand out. You have to copy this now.
Done.
Number 4, x is equal to lambda d upon a. I am now keeping d and a constant. It means x is proportional to lambda. So if I increase wavelength, increasing wavelength means red color is the high wavelength side. And if I decrease wavelength, it means I will move toward violet color, for example. So if I increase wavelength, the fringe separation will increase, less fringes on the screen because fringe separation increases. Another feature is there, degree of diffraction is proportional to lambda upon W. So when you increase lambda, degree of diffraction increases, which means the waves will spread out more. You have to copy this.
Done, sir.
Answer.
Now look at this. Vibgire, the 7 colors. Then if you go from violet to red, lambda increases. Look at this screen. Lambda increases and you can see down the wavelength is increasing. So it means when lambda increases, degree of diffraction increases. Wave will spread out more. Now physics says if the wave spread out more, it will lose the brightness. If you are running a car and you know how to drive, you know there are two modes of the beam of light, one high beam and second low beam. So when you spread the light, you will see the brightness decreases. Same to projector. If you see the projector is moved backward, the screen becomes bigger, but it becomes fainter. Now, this is a very technical concept. You have to copy this.
Done, sir.
Answer.
So look at this now. Because waves always need some visualization, so I'm going to post you. This changes some of the short animations. Now look at this red and violet. What is the difference? Red color has a bigger wavelength and violet color has a shorter wavelength. So red waves will produce a fainter screen and the violet wave will produce a brighter screen. Now you have to copy this.
Answer.
Done, sir.
Number 5, width of slit. This is something I had mentioned many times that the the slit should be very, very narrow. And this is the only way. So if you make it narrow, you will get more diffraction, but simultaneously, just like the famous blinds on the windows, when you open the blind, so when you open them less, you will get less light inside. But when you open them wide open, you will get more light. So the width of slit will affect two things: how much light will go through and how much is the degree of bending. Look at the degree of bending. Narrower slit cause greater degree of bending, and wider slit give wider slit, it will give you less bending. So when the width is greater, more light will pass, less spreading. So you will have a smaller envelope. The screen will be smaller, but it will be a brighter screen. So you have to copy now this screen.
Done, sir.
Done, sir.
Now, when the width is greater, more light will pass, less spreading, small envelope. You have to copy this.
Done, sir.
Right.
Done, sir.
Look at this pattern. I'm opening the slit and look at this pattern. When you see the slits, when you open them wide, when you open them wide, more light will pass and the pattern is much brighter. But simultaneously, the number of the fringe separation increases. So right under it, that slit separation should remain small. Slit separation should remain small. Diffraction in light waves, diffraction grating. This is the last title of this heavyweight chapter.
Done, sir.
This is called a diffraction grating. It's the concept comes here. The Young's double slit was a good rehearsal. The people got success and the interference was in light was obtained. Now, these scientists later thought that Young's double slit had used only two slits and they got a successful response. So they later thought, why don't we use a number of slits? So this was the idea which was used to design this concept here, because if you are using a double slit means two slits, then definitely you are having a feature of low intensity on edges. So this was the point where they thought about this new idea. Now, right under it, give a side heading introduction. This is a modified version of Young's double slit experiment. It uses a series of many slits instead of two slits. A very but this is not a technical example, but for understanding multiple slits. A diffraction grating is a concept of multiple slits. For example, blinds on an office window. When you see the blinds, they are multiple slits and you can open them, you can close them to control the brightness, to control the light. So now you have to copy this. Let me know once you have copied it.
Done, sir.
Good. So we are now in the last title of this big chapter. We will inshallah continue this in our next class. Allah Hafiz. Arima, have you copied it?
Yes, sir.
Good. So we are stopping here and we'll continue inshallah in the next class.